Hello everyone. Welcome to the overall arc flash safety solutions for AC and DC from low voltage to high voltage applications using our ETAP ArcSafety package. I'm your host Raghu Veera Raghavan and will be demonstrating the full spectrum of the program, providing solutions to various challenges faced by the industry. The agenda is to show the arc flash standards and ETAP solutions for low, medium, and high voltage applications, renewable energy, solutions for performing arc flash mitigation, ease of use of tools in ETAP while performing arc flash analysis, and tools to generate arc flash labels and deliverables per industry standards and requirements. I will also be answering frequent challenges and questions faced by electrical safety professionals and demonstrate the solutions for those challenges provided by ETAP. ETAP Innovative Solutions for Safety is available for all types of applications, including generation, transmission, oil and gas, data centers, renewables, and constantly provide effective solutions for all the challenges faced during the power system analysis process. In other words, ETAP offers a one-stop shop with integrated software package that fulfills all the needs that are available in each application related to electrical safety. Now, to demonstrate the fully integrated solutions that we offer, let us take a joyride on this vehicle and explore the innovative solutions offered by ETAP. To begin with, I would like to start from the industrial and commercial application that requires arc flash study based on the OSHA 1910.269. And I would like to demonstrate the arc flash calculations using available standards in the market. The first one that you see here would be none other than the arc flash analysis performed using the IEEE 1584 2018 and 2002 up to 15 kV, as the voltage range is from 0.208 kilovolts to 15 kilovolts, and the corresponding electrical safety workplace standard that is related to NFPA 70 2021 that also comes with evaluating the shock risk assessment and stored energy hazards for capacitors, and also choosing the right personal protective equipment PPE from the equipment labeling section. For the IEEE 1584 2018 standard or the 2002 standard, or using the NFPA 70 2021 shocks protection boundaries, the greatest challenge that most of the times that we face is how to collect the arc flash data. Arc flash data collection process for performing an arc flash analysis could be very challenging for a large system like this that you see in this ETAP model. Evaluating the correct electrode configuration and choosing the right data for the gap, working distance, the corresponding box sizes such as height, width, and depth could be very difficult in a real-life scenario where you are able to collect it from the facility. So ETAP provides a great solution to all these unknowns, given the fact that looking at this substation, for example, here on a 480 volt MCC or a 4160 switchgear, the data is already available in ETAP that is provided from the 1584 2018 global data. These are the standard values provided, and at the same time, these values are generic values based on the given electrode configuration. So in ETAP, defining this data is much more efficient, and at the same time, evaluation of the arc flash analysis during the protection and coordination stage is the greatest key to reduce a lot of man hours in evaluating the right incident energy. So the current version here in ETAP, we also provide all this data available as a compartmentalized arc flash using the enclosure editor. You can see them actually available in the enclosure editor page, where each compartment for the given MCC could be defined and the corresponding electrode configuration can be chosen. For example, this particular bus bar can have a low voltage gear, which could basically have several dimensions for the actual box size and the size of each enclosure, varying from different size, could be saved in the hyperlink selection. And we can also have the existence of multiple electrode configuration in one enclosure, and that can be simulated in ETAP without even running ArcFlash, and this can be done during the coordination and protection stage. One good example is, let us assume that the goal for this particular bus C is to have an incident energy not greater than 8 calories per centimeter square, for example. That would be the client's requirement. So getting to that number could be very difficult without knowing the proper knowledge of the equipment and the proper data collection that needs to be done based on the ArcFlash parameters that is required. So the solution that ETAP offers is called the C area plot, where the user can specify that the maximum incident energy at that location cannot exceed 8 calories per centimeter square. However, based on the typical gap, height, width, and depth and working distances available from the 1584 standard for that equipment, we can apply several tolerances to get a clear spectrum of incident energy as a function of current and time. The good thing is ETAP has the bolted fault currents that is coming from the short circuit study and the protective device study settings from the protection and the coordination study, and that could be made use here so that we can represent this entire incident energy as a function of current and time in the time current curves. So this solution is provided using the Auto ArcFlash module that is available in ETAP, which could be simulated using a common rulebook. Here, you can define the actual rules provided for each incident energy plots, and once this rulebook is shared, a user can simply highlight all the separate locations in one single click and be able to perform an ArcFlash auto evaluation and evaluate the incident energy calculations and the corresponding protection and coordination evaluation in the star auto here. So one good example is bus number C that we worked upon. As you can see here, as long as your protective device, the incoming breaker, is left and below of the referenced incident energy value, your evaluation has passed. Another question possibly arises is, hey, I do have a similar equipment, exactly the same MCC, but I have like 10 MCCs in parallel. And I have spent enough time on this particular switchgear or this MCC per se, and I have created my enclosures in this case. So this is none other than my MCC from the manufacturer. Can I use this as a template to create it with several MCCs that is of this coming from the same manufacturer? Long story short, it's an indirect way of creating ETAP libraries for several ArcFlash equipment or a switchgear equipment in this case. So for example here, in this case, I can select this entire enclosures that has been created for this particular model, and that template could be created as low voltage switchgear from the corresponding manufacturer. And once that is done, ETAP would create an enclosure template which could be used on another particular enclosure, and then that could just bring the data that is saved in here. And ETAP also has the multiple electrode configurations, such as the condition that I showed in this particular picture, where a particular breaker can have both VCB and VCBB on the same location, and that could be also modeled in ETAP using the enclosure editor. This could also be exported to an Excel sheet for report and deliverable purposes. Another feature that is available in ETAP that is commonly required for performing several scenario modeling, such as normal mode, maintenance mode, or using a different transition such as open transition or closed transition or main time main, can be easily achieved using the scenario wizard particular case. So where we can have a normal situation or a landing situation, or having different revisions as found settings or the recommended settings, depending upon the different ArcFlash scenarios that can be created. So that would help us to get a different set of combinations and evaluate the worst case incident energy respectively. Now let us continue with our next stop on the ride, where we can have another application that is related to electrical safety, which could be the underground cable magnetic field intensity for a worker at a public safety and public safety as well. One good example is on the raceway system. Once you perform the steady state temperature calculations on a raceway, ETAP has the ability to create the magnetic field data and then provide the relationship between the magnetic field and the corresponding distance where the actual worker is for a particular raceway is concerned. So one good example is having all those raceways available here. The user can have one single plot or have individual plots or even have a plot range for different distances and the corresponding magnetic field exposure. So let's move on to the next application that is available in ETAP, which is related to the lightning risk assessment for a particular building based on the NFPA 780 standard 2020 or IEC 62305-2. So this particular standard is also useful to evaluate the existence of a lightning risk assessment that needs to be performed and the corresponding measures that needs to be taken on installing surge protective devices. So the lightning risk tool evaluates the existence of an actual risk assessment based on the lightning frequency map provided by the standard and also the corresponding flash density that is available on particular locations. So for example, the tooltip here provides the ability to give us the overall big picture of having different flash densities per year and also helping us to create the structure that is required to perform the corresponding lightning risk assessment required or not. So to begin with, we can simply start an actual structure that is having a top view or an elevated view and evaluate the height of it and provide if we could be able to evaluate the lightning protection system is installed or actually not required. Now let's switch to the joyride again and we will see how ETAP provides another solution for locations where IEEE 1584-2018 method is not applicable. The official standard used to be having Lee method as to be the alternative method beyond 15 kV, but in 2018 standard it was removed, and because of overly conservative resource provided by the Ralph Lee program, ETAP does have another solution using the arc fault module that would be useful to provide arc flash results for transmission and distribution systems beyond 15 kilovolts. ETAP has the evaluation tool available for a 132 kV system where we have the arc fault module and then we are able to use the EPRI method or the Terzier-Conglin method for international users. The good thing about ETAP is it also provides a system study evaluation along with these extended methods and provide a full spectrum of the analysis point of view on the incident energy calculation and see the corresponding behavior for a line to ground fault at a given incident energy or working distance basically. The sequence of op tool is very useful as an ease of use tool that could be used to perform arc flash analysis and evaluate the sequence of operating of devices for all arc flash applications in ETAP. The next application that we have is going to be related to the overhead transmission line where we will be able to perform substation ground grid studies to evaluate touch and step potential. We have the IEEE 80 finite element method or the Neher-McGrath element method, which is also available in ETAP that can be performed in the ground grid studies that is available along with the software package. It also gives you an overall big picture of giving the ground grid potential, rise and step potential for a particular ground grid system and the corresponding trench and the solar shape and the different shape of grids that can be installed in ETAP. Now let's switch to the next particular location, which is the DC and the arc flash methods that is available in ETAP, especially for renewables and battery energy storage system. I forgot to charge my car over here and I would like to go green in this case. So Probably now that I remind myself of the renewable sources, I can charge the car electrically if this one is to avoid gas emission and reduce fuel consumption. In that way, if you wanted to perform an arc flash analysis in these renewable locations, we have the DC arc flash designated methods such as Stokes, Pockret, Max Power, and also the German arc flash for DGUV 077 standard. We have PV array curves that is available in ETAP that could be also estimated and be able to generate the IV curves using a single or two diode models, and also perform arc flash analysis using the available DC arc flash methods that is included in ETAP. So in the new version, we will also have the DGUV I203-077 for the iterative and the worst case from the German arc flash, and also we can perform incident energy subtraction, arc elongation effect, or even the erosion effect that is included for the corresponding electrode material. So ETAP also performs arc flash analysis for several locations, such as the combiner box in ETAP, where you can also display the worst case incident energy in the one line diagram using the data block feature. In other words, we can also use arc flash labels for corresponding battery banks as a storage device and evaluate the discharge and the charging capabilities using different battery modeling using the IEEE 946 standard. So the short circuit modeling of the battery is now enhanced based on the state of charge for lithium ion batteries, and the renewable energy has been covered using the arc flash incident energy calculations using the DC arc flash methods. And the next method that I would like to visit here is basically generating the deliverables. Now that we got all these different applications available, now the end point is to generate how to perform arc flash analysis, analyze them with all the tools available in ETAP, and finally generate arc flash labels based on the complying standards that is associated with generating arc flash label maker. Arc flash labeling and deliverables from ETAP has a wide range of solutions offered to frequently asked questions, such as having different formats, different layout of the label, size, dimensions, and having different incident energy and the corresponding warning signs and templates that needs to be used. So that is easily accomplished using the ETAP e-label maker that is introduced in this version, which could also be used to generate the arc flash label. So after performing all the arc flash analysis and getting the worst case scenario, the user is able to select the corresponding incident energy value and select the e-label maker, and that would basically bring up a template and the corresponding merge fields coming from the corresponding locations. ETAP also supports multiple databases for specialized labels such as maintenance mode on or off, and that could be easily previewed and printed using the label maker. The print preview button is also enhanced because many users have the requirement for generating multiple labels per page depending upon their page size and their printer size, and that could also be accomplished using the label maker, having number of labels per page, number of rows, and number of columns, and able to print them accordingly to that particular case. Similarly, the deliverables that we mentioned, we add an arc flash label with QR codes that is digitized, as I mentioned, to summarize it, and that would also be used to scan it and digitally have your labels in a server using the arc flash analyzer basically. The next one that is available in ETAP as a tool to perform electrical safety 2 or arc safety program is actually the current transformer saturation technique, where ETAP is equipped with performing CT saturation module. A quick demonstration for performing CT saturation can be accomplished using a CT editor, and once you enter the CT ratings based on the corresponding primary and secondary turns ratio and selecting the corresponding burden, the CT sizing is made more simpler and provide the corresponding evaluation of how the ideal and the actual amps of the CT saturation could be selected basically. So in this case, if we put different voltages and the corresponding calculation could be giving you the ideal current and time characteristics, and at the same time, we can also see how the CT saturation is operating based on the ideal and the actual amps. Or in other words, we do have the ideal RMS value and the actual RMS value selected, and also the excitation current can be shown according to the CT saturation. In addition, we do provide several shock risk assessments, stored energy calculations for capacitors. Using ETAP, we provide and comply with several international standards that is included as a package to perform shock risk assessment protection for it. The capacitor storage analysis based on NFPA 70 2021 is also available in ETAP to provide the actual shock and blast based on a given rated capacitor, and also the thermal arc flash energy results that could be evaluated using the calculations for different capacitor and its energy storage systems. So in addition, once the analysis is performed and we got your worst case incident energy, ETAP also offers several mitigation techniques such as differential protection, zone selective interlock for solid state tripped units, maintenance mode, light detection, and for working distance related, we also have remote racking and arc resistant switchgear. And also to reduce the risk, we could also have high resistance grounding and current limiting fuses as mitigation techniques in ETAP. So one good example of all these mitigation techniques that could be implemented in ETAP comes from a factor that, all right, for every time I would like to select different incident energy working distances based on working distance 1, working distance 2, can ETAP evaluate the arc flash and incident energy quickly? And I do have a large system, and how can we able to see a spectrum of incident energy for a given multiple working distances? And that is basically available using the arc flash power calculators on top of the arc flash analyzer and the fault insertion that I showed before. And to switch to ETAP, we do have the option to select the arc flash calculators, and from the corresponding methods selected from the actual incident energy evaluation. And the calculator tool has the option to perform different arc flash incident energy to evaluate the plots for a given working distance from a given particular set of minimum to maximum working distance per se. So in this case, ETAP gives you a plot, all right, starting from the minimum clearing time to the maximum working distance or the maximum clearing time, and then give a different plot view for different incident energy without even running ETAP. So these what if scenarios help to reduce a lot of assumptions, and at the same time provide a good estimate of incident energy without running the actual program from the scenarios that is being designed. As a conclusion, what are all the solutions that ETAP can offer based on different challenges and questions have? Are you facing challenges in arc flash data collection? You have the C area plots. Have the incident energy as a function of current and time, modeling various system configurations? Yes. Main time main, open transition, closed transition, maintenance mode on, maintenance mode off. You can make use of the scenario wizards available in ETAP and evaluate your worst case incident energy. Creating, sharing templates for arc flash equipment. Can I do that? Yes, you can. You don't need to have an arc flash library, but you can use your enclosure editor and create templates for same equipment such as switchgears, MCC, and panel boards, and share it across different users. Are you finding it hard to analyze the worst case incident energy? As I demonstrated, you can use the arc flash analyzer for multiple reports, evaluate the worst case incident energy, and then send it to the data blocks, and so that the one-line diagram can have the worst case incident energy shown on the display, and that could be printed as a drawing with the arc flash results. What should we do for arc flash for applications beyond IEEE 1584 limits? Depending upon the application, we have solutions from the arc fault method, the DC arc flash, single phase arc flash, DGUV methods, and also Australian arc flash included in the package. What if calculations? The arc flash calculators provide several powerful tools to evaluate different combinations of incident energy, electrode configurations, working distance, gap, and also different clearing time and arc duration, and provide what if scenarios using the calculator tool and the batch process that just requires a simple spreadsheet. Can I apply global rules for ArcFlash evaluation? If we use the Auto ArcFlash package, one protection engineer generates the ArcFlash rules for ArcFlash and STAR, all the team members, and they are able to perform analysis having different working distances, and you are able to analyze visual ArcFlash plots. The ArcFlash is using the plot view tab of the ArcFlash calculator. Are we complying with the international standard? Yes. Generating ArcFlash labels per requirement. The e-label maker makes it easier. So as a conclusion, I would like to say, for all the questions that you have in performing ArcFlash analysis or any electrical safety, with all the different scenarios and all the problems that we face, ETAP always has the solution required for your current application. And I thank you everyone for attending this session and appreciate your feedback.